So for this problem here, I want to go through another example. In our first example, everything was inside the absolute value. So that 11 represented the whole distance or the absolute value or that distance from one problem to the other. For our second example, I want to highlight or I want to point out that we now have a coefficient or a number outside of the absolute value statement. So this here is our coefficient. And it's just one coefficient. You can have a coefficient with the x again, but that's just one coefficient. So we have to take care of this coefficient before we deal with this absolute value statement. Because this 18 right now is not representative of the distance, it's just representative of the entire expression. So to get rid of or to undo this coefficient, we're going to first divide it out. Whatever we do on one side, we have to do on the other. 6 divided by 6 gives us 1. So I'm left with my absolute value statement, the absolute value of x plus 2 equals 18 divided by 6 is 3. So now that 3 represents the absolute value or the distance. So once again, we can think about this on a number line. If we have our number line, and this is 0, our distance could be 3 in this direction, or it could be 3 in this direction. So we have two possible statements. X plus 2 could equal positive 3, or x plus 2 could equal negative 3. Because again, that absolute value is just that distance of 3. We go ahead and we solve each one. So x could equal 1, or x, and again, I have to remember my integer rules, could equal negative 5. To be fully correct, both of those options are available. Okay? Great.